Good morning, children. In today's class, we are going to learn some important theorems in differentiation. Rolle's theorem. It has some conditions to be checked. Number 1. F of x is continuous on the closed interval AB. So, if I draw a curve like this, these are the 2 points A and B. And what are the conditions laid in the question? This is the function y is equal to f of x. Continuous. Between A and B, it is continuous. And it is differentiable in the open interval AB. Closed means A less than or equal to x less than or equal to b, n values inclusive. Open interval tells me A less than x less than b, n values are not inclusive. The third condition, this is f of A, the height, and this is f of B, the height. Both are equal. Whenever f of A and f of B are equal, I can have at least one point C somewhere here where I draw the tangent. The tangent will be parallel to x-axis. The curve may be like this also. But whenever f of A and f of B are equal, I can draw a tangent which is parallel to x-axis. Parallel to x-axis, we learnt the condition derivative is 0 in the previous exercise. So what is Rolle's theorem? F of x continuous on the closed interval C. Remember, continuous on the closed interval, differentiable in the open interval. Open interval, put round bracket. F of A equals f of B. Then there is at least one C. You can have more than one C also, which is inside A and B. C should not be equal to A. C should not be equal to B. The theorem says C is inside A and B where f dash of C equal to 0. In other words, whenever the two heights are equal, I want to claim, according to Rolle, there is a tangent which is parallel to x-axis. Now the question is, in all the curves, I need not have f of A and f of B to be equal. Look at the two heights. This is f of A and this is f of B. Here, one is bigger, one is smaller. What should I do? In this case, first condition, okay, it is a continuous curve. Second condition, okay, it is a differentiable curve. So, continuous in the closed interval, differentiable in the open interval. But f of A and f of B are not equal. What should I do? Now, again we have the tangent. What is the tangent slope? We have learned it is nothing but derivative. So, what is the formula? This is given by Lagrange. The formula is f of B minus f of A by B minus A. Remember, slope we say y2 minus y1 by x2 minus x1. This is y2, y1, this is x2, x1. So, y2 minus y1 by x2 minus x1 only. Restated in Lagrange's mean value theorem, f dash of C is f of B minus f of A by B minus A. Again, C is inside the interval. C is not equal to A or B, rather C is inside the interval. So, how do I compare it geometrically? This point I call B comma f of B. This point I call A comma f of A. A little before we said y2 minus y1 by x2 minus x1 is nothing but slope of this line. The line joining the end points we call secant line. So, for this secant line, I can say there is a tangent parallel to this secant line. This secant line is joining the end points. So, tangent is parallel to the secant line in Lagrange's mean value theorem. We'll see the statement now. Lagrange's mean value theorem says f of x is continuous on the closed interval, f of x is differentiable in the open interval a comma b, there is at least one c inside a and b. That is, it belongs to the open interval a comma b, where f dash of c equals f of b minus f of a by b minus a. This meaning is closed interval and this meaning is open interval. You must know whenever we are using it in the exercise. So in different versions, we call it as LMV, Lagrange's mean value theorem, or in short MVT, mean value theorem. So we call in both the ways, either LMV theorem or MVT. MVT stands for mean value theorem. Having learned the various theorems, let us do problems based on them. Exercise 7.3, question number 1. Explain why Rolle's theorem is not applicable. F of x equals to 1 by x. X is in the interval -1 to 1. Whenever you have denominator, check whether denominator is 0 in the given interval. So denominator 0 implies x is equal to 0. 0 is inside the interval. Therefore, f of x is not continuous at the point x is equal to 0. And where is that 0? It is inside the interval. Therefore, Rolle's theorem is not applicable. So every problem, check for continuity. Continuity itself fails, no need to proceed further. Second question, f of x equals tan x, x belongs to the interval 0, pi. Whenever we say tan x, we know it is not continuous at pi by 2. Pi by 2 is inside this interval. Therefore, we will say f of x is not continuous at or in. F of x is not continuous in 0, pi, and therefore Rolle's theorem is not applicable. So remember, continuity itself fails. We need not proceed further. We can immediately say Rolle's theorem is not applicable. Third question, f of x equals x minus 2 log x. X belongs to the interval 2, 7. No denominator, no square root. So this is continuous. We know x continuous, log x is also continuous. So x minus 2 log x is a continuous function in the given interval. It is also a differentiable function in the open interval. What is f of 2? Wherever x is coming, put 2. 2 minus 2 log 2. F of 7. Wherever x is coming, put 7. 7 minus 2 log 7. Obviously, they are not equal. So, I say f of a not equal to f of b implies Rolle's theorem is not applicable. So, every problem we are just listing out why it is not applicable. Here, even though it is continuous and differentiable, the initial value and final value are not equal, and therefore Rolle's theorem is not applicable. Exercise 7.3, question number 2. Using Rolle's theorem, find x at which tangent is parallel to x-axis. Tangent parallel to x-axis tells me derivative equals to 0. Using Rolle's theorem, f dash of c is 0 at c belonging to open interval a, b. Given f of x is x square minus x. No square root, no denominator, so no problem at all. It is a continuous function in the closed interval and it is a differentiable function in the open interval. Remember, continuous closed square bracket, differentiable open round bracket. Find out f of 0. Wherever x is coming, put 0. 0 minus 0 is 0. Wherever x is coming, put 1. 1 square minus 1. That is also 0. Implies f of 0 equals f of 1. All the conditions for Rolle's theorem to be applicable are satisfied. Using Rolle's theorem, find the derivative. What is the derivative? F dash of x is equal to x square becomes 2x and x becomes 1. Putting f dash of x 0, 2x minus 1 0, or 2x equal to 1, or x is equal to 1 by 2. Check whether 1 by 2 belongs to 0, 1. Yes. So 1 by 2 belongs to the given interval 0, 1. Therefore, the C value, as in Rolle's theorem, I call 1 by 2. My question is find that x. So at x is equal to 1 by 2, the tangent is parallel to x-axis. And that is the answer. Exercise 7.3, question number 2, subsection 2, f of x equals to x square minus 2x by x plus 2. Whenever denominator comes, put the denominator equal to 0. I get x is equal to minus 2, but my question starts from minus 1. So minus 2 does not belong to this interval. Therefore, f of x is continuous. So in the given interval, f of x is continuous. Denominator becoming 0 is not inside this interval. The second idea, it is u by v. Since the denominator is not becoming 0, I can differentiate it. So we will write f of x is differentiable in the open interval. Open interval we put round bracket minus 1, 6. Find out f of minus 1. Wherever x is coming, minus 1. Minus 2 into minus 1 by minus 1 plus 2. 1 plus 2 by 1, that is 3. F of 6 equals, wherever x is coming, put 6. 6 square minus 2 into 6 by 6 plus 2. 36 minus 12 by 8. 24 by 8, that is also 3. So these two imply f of minus 1 equal to f of 6. All the three conditions are satisfied. So using Rolle's theorem, what will you say? F dash of C equals to 0. C belongs to open interval a, b. Find out the derivative. F dash of x is equal to, this being a quotient rule, x square minus 2x you treat as u, and v is the denominator x plus 2. Find out u dash. U dash, x square becomes 2x, 2x becomes 2. V dash, x becomes 1, 2 becomes 0. And what is the formula for u by v the whole dash? Vu dash minus uv dash by v square. We will apply these values in the derivative. F dash of x is equal to vu dash x plus 2 into 2x minus 2 minus uv dash x square minus 2x into 1 divided by v square x plus 2 the whole square. Simplifying this, as I multiply 2x into x, 2x into 2, minus 2 into x, minus 2 into 2, minus x square plus 2x, whole thing divided by x plus 2 the whole square. As we expand this, 2x square minus x square is x square, plus 2x minus 2x cancels, plus 4x minus 4 divided by x plus 2 the whole square. Put f dash of x equal to 0. Denominator will not affect the numerator. X square plus 4x minus 4 is 0. Solve for this x square plus 4x minus 4. I cannot factorize it. Use formula method. For formula method, here no number. This number I take A, this is B and this is C. What is X? Minus B. Plus or minus root of B square minus 4AC divided by 2A. Or we get the answer minus 4 plus or minus 16 plus 16, 32. 32 can be written as 4 root 2 divided by 2. Cancelling all the 2, we get minus 2 plus or minus 2 root 2. 2, 2, 2 as I cancel, I get like this. Now this answer, check whether it belongs to the given interval. Minus 2 root 2 does not belong to the interval, but minus 2 plus 2 root 2 belongs to the interval. So at least one value belongs, then we are done. So as I check the two values, I am able to conclude minus 2 plus 2 root 2 belongs to the interval minus 1, 6. Therefore, tangent is parallel to x-axis at minus 2 plus 2 root 2. So at one point we have found out where the tangent is parallel to x-axis. Exercise 7.3, question number 2, subsection 3. F of x equals root x minus x by 3. X belongs to 0, 9. There is no denominator. So it is a continuous function on 0, 9. Root x is there, but x becomes 0. 0 is inclusive. F of x is differentiable in the open interval. We need to check f of 0. Wherever x comes, put 0. Root 0 minus 0 by 3 is 0. F of 9 is root 9 minus 9 by 3. 3 minus 3, that is also 0. Now we say f of 0 equals f of 9. All the conditions for Rolle's theorem is satisfied. We will proceed on to using Rolle's theorem. We have the condition f dash of c equal to 0. C belongs to the open interval a, b. Find out f dash of x. F of x is root x. F dash will be 1 by 2 root x. X will become 1 by 3. Finding f dash of x equal to 0. 1 by 2 root x minus 1 by 3 equal to 0, or 1 by 2 root x equals 1 by 3, or root x equals cross multiplying 3 by 2, that is squaring. X will become 9 by 4. It belongs to the interval 0, 9. 9 by 4 is 2 point some number, 2.25. It is inside the interval. So we take and write c equal to 9 by 4, which is the point where the tangent is parallel to x-axis. The question says find the x value for which the tangent is parallel to x-axis. The condition is the first derivative 0. For a particular point which is inside the interval, we have shown 9 by 4 is inside the interval. Using Rolle's theorem, tangent is parallel to x-axis at x is equal to 9 by 4. Question number 3. Explain why Lagrange's mean value theorem is not applicable. Given f of x, we have something in the denominator. Put the denominator equal to 0. We get x is equal to 0. Check whether 0 is inside this interval. Minus 1 to 2. Definitely 0 belongs to the interval. Therefore, f of x is not continuous at x is equal to 0, and that is inside the interval. Therefore, Lagrange's theorem is not applicable. Second subsection, f of x equals mod 3x plus 1 x belongs to minus 1 comma 3. Whenever we see mod x, it is a continuous function. So mod 3x plus 1 will be somewhat like this, which is a continuous function. General formula, mod x is a continuous function, but mod x minus a comes, it is not differentiable at x is equal to a. That is, put what is inside the bracket 0. Whatever answer I get, it is not differentiable at that point. So what is inside the modulus 3x plus 1? Put equals to 0. I get 3x is minus 1 or x is equal to minus 1 by 3. Using this formula, we will say f of x is not differentiable at which point? The point where it is becoming 0. Is not differentiable at x is equal to minus 1 by 3. Check whether minus 1 by 3 is inside. Yes, minus 1 by 3 is between minus 1 and 3. So I will write it belongs to the interval minus 1 comma 3. Therefore, Lagrange's theorem is not applicable. Lagrange's theorem, there are a variety of words. Mean value theorem we say, or Lagrange's theorem we say, or Lagrange's mean value theorem also we say. The steps, mod x is always a continuous function but not differentiable at the point where this factor, whatever is given inside the modulus, is 0. So put whatever is inside the modulus 0, I get x is minus 1 by 3. Check whether it is inside the interval. If so, declare f of x is not differentiable at that point, and therefore Lagrange's theorem is not applicable.